Well, as we start our last lesson for this class, just kind of pretty much a continuation of where we just left off in our last lesson right prior to this. Our whole goal right here is to solve non-right triangles. The last lesson we focused on doing with law of cosines, and as you probably saw, that law of cosines is really dealing with knowing the sides of a triangle. If you know specifically, if you know two sides and an interior angle, or if you know three sides, then you can get an interior angle. So it really focuses more on the sides of a triangle. Whereas the law of sines focuses more on the fact of, if you look here at what the equation says, it's side A divided by the sine of the angle opposite of it, side B divided by the sine of the angle opposite that, and side C divided by the sine of gamma. Okay, and how you do the law of sines is you just pick any two of these pairings. So you could either say, like, let's say those two, call that equation, solve it from there. Or maybe you want to go A and C compared together, or B and C to compare. All you just need is a pairing of those two, and that's all you need. Okay? And the key with the law of sines is we have a very unique trait with that. The law of sines is all about this note. Pay very, very, very special attention to this note. Is because we can technically get two potential answers when we're dealing with the law of sines. Never, never with the law of cosines, but potentially. Not always going to happen. In very few cases will it happen, but sometimes it's there. And when that does, we want to follow these steps. Okay, so take some time to read through those steps if you haven't done already. Make sure you get those embedded in your brain. We're going to come back to them, so we're about to practice it. Okay, so speaking of practicing, let's go to example 1. We're going to use the law of sines to find gamma. And we know side A, we know side C, and we want to find alpha. Okay, well look here. We know side A and alpha. That's a good pairing. We know side C, and the angle that goes with that is gamma. So pretty much they have it set up for you. They wouldn't have given you a beta or a B in here otherwise. Okay, since I want to find an angle, I'm going to start with the angles on top. So sine, it's always sine because we're doing the law of sines. Sine of gamma divided by its side, which is 54, is going to equal sine of our other angle, which is alpha, over side A, which is 37. So if you want me to write out what we're using sine of gamma over C is equal to sine of alpha over A. Alpha goes with A, gamma goes with C, and we're doing the law of sines. So from here, all I have to do is solve for gamma, and I'm good to go. Multiply both sides by 54, and sine of gamma is going to be, it's 54 over 1, so it'll be 54 times the sine of 33 degrees all over 37. And remember, anytime we want to solve for an angle, we want to get rid of sine. To take it off that side, we use sine inverse. So it's going to be the sine inverse of 54 times the sine of 33 degrees, all divided by 37. Okay, so let's plug this in our calculators. Again, we're finding an angle, so we want to round it to degrees and minutes. So when I do this, what I technically get is 52 degrees, and it looks like 39 minutes. But if we go up to the information, everything is in basically two significant digits. So if I want to round this to two significant digits, it's really going to be just 52 degrees. Alright, so we can box this up and call it done. But now this is what I was saying. With the law of cosines, or the law of sines, we have a second potential answer. And how you possibly get the second answer is you take what you just found and you subtract it from 180. So 180 minus 52 degrees is going to give you 128 degrees. Okay, this right here is what we're going to try to see, can that potentially be a second answer? Alright, so let me kind of go back up to your notes real quick so you can see what I'm doing, the steps I'm doing. Okay, so take our first answer. Our first answer was that 52 degrees, and we're going to subtract it from 180. We did that, and this is our potential second solution. So this is where we got the 128. Now take this potential second solution, so take this 128 and add it to the angle value that you were given in the initial problem. Okay, well the angle value that was given to us in the initial problem was 33 degrees right here. So it says take my 128, add it to the angle value that was given to the initial problem, which was 33, and that gives you a total of 161. If the sum is less than 180, which it is because it's 161, then our second angle works and there are two solutions. Okay, so we can write these down in notes. We'll just say, okay, so if 128 plus what was given is less than 180, if this is true, let's say if true, then 128 works. And like I said, 128 and 33 is 161, so we want to box this up, and we have two potential answers. So gamma is 52 degrees, and it's also 128 degrees. So we really do have two solutions for this problem. Okay, well, let's take this idea and let's try it one more time and see what happens. In this example right here, we're going to use the law of sines to find alpha. We're given A, which is grapes, we're trying to find alpha. We're given B and beta. Okay, so if I start out by just using my formula, it'll be sine alpha over A is going to equal to sine of beta over B. Okay, so sine of alpha over side A, which is 622, should equal sine of beta, so sine of 48 degrees in 10 minutes, over side B, which is 518. Finishing this out just like before, let's multiply both sides by 622, or like 622 over 1, so that cancels that out over there. And sine of alpha is going to be 622 times the sine of 48 degrees in 10 minutes divided by 518. So to get sine, or the alpha by itself, we're going to do inverse sine of that big fraction. So 622 times the sine of 4810 all over 518. So let's plug this into our calculators. It's looking like we're working with three significant digits, so this time we're definitely going to want to use degree minutes. Okay? And with this I get 63 degrees and 28 minutes. Alright, box this up and let's go to work on trying to see if we can get a second solution. So I'm going to take, here's my possible second, I'm going to take 180 and I'm going to subtract off 63 degrees and 28 minutes. So that's going to give me, if I change that, right there to 179.60, so I can do the subtraction. So 179 minus 63 is going to give me 116 degrees, and then 60 minus 28 will give me 32 minutes. Okay, and I want to compare this. If I can take my 116.32, so here's my potential one, this is the one we're kind of questioning right here. If I can take that 116.32 and add on the angle that was given to us in the problem, and if this is less than 180, then it works out. So 116 plus 48 is 164, and 10 and 32 is, 42. Since that's less than 180, it checks off, so we can also say then that alpha equals 116 degrees and 32 minutes. Continue that in the box, and we are done. Alright, so let's go on to example 3. Okay, with this example, let's kind of look at what we want to find. We want to find side B. We are given the fact that side C is 2,727. We have alpha and we have beta. Well, if we want to find side B, let's write the ratio more this way. Okay, side B over sine of beta equals, and then what's given to us is side C, so it would be C over the sine of gamma. Well, I don't know gamma. All I know is alpha and beta. So let's think, how can I get gamma if I know only alpha and beta? Well, we know that all three interior angles of a triangle have to add up to 180, so we can say alpha plus beta plus gamma has to be 180 degrees. Alpha, 33 degrees and 33 minutes, plus beta, 58 degrees and 52 minutes, plus gamma should equal 180. So let's subtract both of those over, and we'll get gamma to be 180 minus 58 degrees and 52 minutes minus 33 degrees and 33 minutes. So all in all, gamma is going to be, this looks like, if I combine kind of these two together, 58 and 33 will give us, let's see, 92 degrees and 25 minutes. So if we subtract that from 180, or if we change that, to 179.60, then we'll get 179, so then minus 92 will be 87 degrees, and 60 minus 25 is 35 minutes. Okay, all of that work just to find gamma. So if you can go back to original problem, b over sine of beta, which is 58 degrees and 52 minutes, should equal side c, which is 2,727, over the sine of now gamma, which is 87 degrees and 35 minutes. So just multiply the sine of 58, 52 over, and we can get b. So side b is going to be 2727 times the sine of 58, 52 divided by the sine of 87 degrees and 35 minutes. So let's put all this in our calculator. Since we're finding a side, there's no potential second answer. When you're finding a side, there's only one answer and one answer only. It's only with angles that you get a potential second one. Okay. With this, I get b to be 2,336.29, and we'll just round to those four significant digits. So box that up, and that looks pretty good. Since the other side was 2727, this looks pretty good. All right, on to some word problems.